Ta-da! Welcome to Git Basics. I'm here to teach you the basics of Git. Maybe more, maybe less. We'll see. My name is SkidViz. Most people just call me Viz. My Twitter handle is @SkidViz, so if you want to follow me, that's how you would do it. Unlike that bear, I won't look pretty and bite your head off. I'm quite the opposite, so feel free to talk to me whenever you want. I am a consultant at Agape Red, one of the sponsors for this event. It's a great company to work for. I've been there since February of last year. Really small, tight-knit community, and we usually meet up on Fridays for lunch. That's what that picture is, so today I missed it, and I'm very sad. But most of us are here today, so that worked out. One of the great things about Agape Red is that they let us work from home, and we all take advantage of that. Me more than others, because I also opened up a co-working space in Omaha last year, or in 2012. For those of you who don't know what a co-working space is, it's a space for people who work from home or work remote or have a startup or just want to get out of the house. You can come over and work with other people, get away from the laundry, get away from the couch, just get work done. So if you're in Omaha, stop by. I have coupons here so you can get in for free. Just come see me afterwards. Little warning, I like GIFs. Things moving, they tell a better story. They're entertaining. So if you're prone to seizures or you get nauseous or you don't like GIFs, there's a door. I apologize. So let's get started. What is Git? I've only been working with Git for a little over a year. I used to be a .NET developer, did .NET for 10 years. I've used other things like Visual Source Safe and Mercurial. But I just discovered Git, or it was kind of thrust upon me at work. And if you don't know what Git is, that's fine. I would have thought it was a way to get rid of dogs. Like there was a lot of stray dogs where I grew up, so when I'd see one, I'd be like, Git, and that's what I thought it was. But that is actually not what it is. It's version control. Have anybody seen this movie? Yeah. It's awesome. Yeah, you kind of need version control. What I like to think of it, though, is it's a time machine. Is this a time machine to anybody? Maybe this one? Just in case. It's a good way to go back in time and take care of some screw-ups. According to the website, Git is a distributed revision control system with an emphasis on speed, data integrity, and support for distributed nonlinear workflows. That makes sense, right? I got it. Actually, I don't. But it will by the time you're done with this class, this session. Or maybe it won't. But we'll try. Where do you get Git? Yeah, I got that right. You go to git-scm.com. I believe the SCM stands for Source Control Manager. I'm not sure. But that's where you get it. Pretty confident that all of you here can install it. It's available for all the operating systems, and it's pretty easy to set up. Some of you here might know how to use Version or SourceSafe or Mercurial or any of the other dozen or 100,000 version control programs out there, and you might have a question, how is it better than this or that? I'm not going to address that at all, mainly because I'm not familiar with all the other ones. And I don't care if they're better. I'm going to use Git. And we just don't have the time for that discussion. But I'll tell you why you should use Git. The first reason is it's awesome, like this cat, with the top hat and monocle. He's awesome. The second reason is everyone else is using it. All right, you got that list right there. Google, Facebook, Microsoft, Twitter, LinkedIn. Camels use it for some reason. Android, penguins. My phone. I said Google. That's why. So yeah, everyone's using it. So even if you don't want to use it, you probably want to work at some of these companies. So you should learn it just for that. It was created by the Linux guy. I won't pronounce his name because I'll butcher it. But everybody knows who he is. He's the guy that created Linux. Really smart guy. Broke. And another reason is a lot of employers look at your GitHub profile now to kind of judge your work and see if you know what you're doing. So you should probably learn Git, put some stuff out there, and you know, give them something to look at. On that note, Git is not GitHub, and GitHub is not Git. They're easy to get confused, but you know, Git is the version control manager software, and GitHub is a website that lets you use Git to put stuff up there. So it's a clear distinction. I'm going to get on my soapbox and talk about something that, you know, I actually just heard the opposite advice next door. Use the command line tools. Like I said, I used to be a .NET developer, and I used to use Visual Studio and Microsoft SQL Manager, all these cool tools that, you know, let you click on stuff and get things done. But I'm also the kind of guy that used Notepad to make his first website, you know, so you need to know how things work underneath before you can use these graphical interfaces, because you know, they're great. They'll save you a lot of time, and they'll help you get things figured out. But when there's a problem, you're not going to understand what's causing that problem, so it's going to be harder to troubleshoot. So if you know Git from the command line, it'll be easier to figure that stuff out. Please save your questions until after I leave. There's not enough time, but no, I'm just kidding. Feel free to ask me anything. If I don't know the answer, luckily he's here. He knows everything, so I'll just forward them to him. So let's get started after he gets seated. All right. So the very first command I want to teach you is called git init. Most of the git commands start with git and then whatever it is you're trying to do. Git init creates an empty repository or reinitializes an existing one. So I'm going to give you an example of that. I'm going to create a folder here on my desktop. I'm going to call it movies. Why not? So as you can see, there's nothing in this folder. It is completely empty. Nothing up my sleeves. So I'm going to change into that directory. Call it movies. Do an ls. Again, there's nothing there. If I do git init, it'll say initialize an empty repository in that folder. Now if I look in here, you'll see there's a new folder that is a .git folder. That's where Git keeps everything. It's what I call the magical Git directory. You don't need to trouble yourself with what's in there. It's all the databases and stuff that Git needs to do its thing. But the beautiful thing about that folder is that if you're done with this project, or you want to give this project to someone else and you don't want your history of all the mistakes you've made, you can just delete that folder and it's no longer a Git folder. It's not a Git repository anymore. So it's really nifty that they keep it all in one place. It's not like, you know, I think Subversion creates folders in every folder, and it's really hard to get untangled. This is all just in one place, so you can get rid of it nice and easy. The next command is git status. This lets you see, it shows the working tree status. Basically, it lets you see all the files that have changed and everything that you're trying to keep track of. So we'll go ahead and just do that real quick. Git status. It tells me there's nothing different. Everything is good to go. But if I go ahead and create a new file called Avengers, and I'm going to type in, I don't know, Thor. He's an Avenger. So we have a new file there called Avengers. You can see that. And if I do git status again, it says there's a file there. It's red, nice and red, so that you can see that there's something to pay attention to there. It's an untracked file. That means Git doesn't know what to do with it yet. So that's what git status does. Now that we have that, and we know there's something we want to add, the next command is git add, and then the name of the file that you're trying to add. It adds the file contents to the index, and I'll explain what that is in a second. So if I do git add avengers.text, it doesn't tell me anything. But if I do a git status again, you'll see that the file is now green. It says it's a new file, and above it says changes to be committed. So it knows that this is something that I want to do something with. There's other ways to use the git add command. You can use git add and then the name of a folder or directory. So if I, for instance, had a folder full of images, let's just go ahead and say I have a folder called images, and I just want to add that. If I do a git status, you'll see there's a folder there. Oops, no, that didn't happen. Anyways, if I want to add that folder, I can do git add images and then a slash, and it'll add everything in that folder. So there's nothing in there, that's why it didn't work. But that's what that does. And the other one is git add period or dot, and that's the one I end up using the most. And I'm actually in a very bad habit of using that one all the time. I use it instinctively. Even if I just want to add a file, I'll usually do git add dot and then the file, and then go duh, but it basically adds a wildcard. It'll add everything that's in that folder and in all the subfolders.
So does that add things going forward then? Or just everything at that moment?
At that moment, yeah. So what exactly does add do? To explain that, I have to tell you about the 3 stages of brain-tingling fun. All your files that are in your folder, that's your working directory. That's what's happening right now. When you use add, it puts it in staging or the index, and we'll talk about the repository here in a second. The way I like to think of the working directory, it's the directory where you're doing your work. I think of it as papers on the ground. You can sort your papers, you can add new papers, you can write on the papers, you can do whatever you want, make all the changes you want. It doesn't affect anything, nobody cares. When you use git add and you put it in the index or staging, you're basically saying, this particular piece of paper, I'm going to put it in a box. I want to use that later. I got something like this is important. This is different than the rest. Something's changed. It's basically the files you want to keep that have changed. And then the repository, you're saying, I know what I'm doing, commit my actions to the annals of awesomeness. It's the equivalent of taking that box, sealing it up, sticking it in the mail. It's sealed, your change is now permanent. So those are the 3 different stages that you deal with. And speaking of the repository, the way to move things from staging into the box that's sealed is git commit. You're recording the changes to the repository and making it a piece of history. So now that we have this file here sitting in the staged area, I can go git commit, and then I have to provide it a message. So -m says I'm going to provide a message, and then just a string saying what this change is about, what's the commit. I'm going to write add Avengers file. And right there it says one file changed, there was an insertion, what's the file name that was added. And there's some other information there that we'll cover here in a bit. You also see the change note, add Avengers file at the top, the commit message. Now there are some rules. They're not going to break anything if you violate them, but they're just kind of the common standard that people use. Be as verbose as you want, but want to be very verbose. Don't just say something changed. Just try to be descriptive. You want someone to look at this and know what's in it without having to dig too much, because when you get a lot of these messages, it could get a little cumbersome. And you want to speak in the present tense. This is something that I struggle with a lot, because when I write my commit messages, I want to say what I did. You know, I changed something, I added something, but what the commit message is supposed to describe is the commit itself, not what you did. So you speak in present tense, say, add this file. That way it's easier when you're looking at the log to know what that commit did or does. Speaking of logs, that's the next command, git log. It shows you the history of all the commits. So if I come here and clean this up real quick, git log, you'll see that there's a commit there. It tells you the author, I did it, sorry, skidviz. It tells you the date and time that it was committed, and it shows you the commit message. So you can see what the commits are that have been committed. There's a nice way to clean that up. Actually, git log has a whole lot of different parameters that you can pass it, and it'll make it a lot more readable. You can change colors, you can do all kinds of crazy stuff. But a real simple one, you should look into that. But a real simple one is git log -- one line. And as it says, it compacts it down to one line. So if I do that, git log -- one line, you see it's just one line, and nice and simple. You're probably wondering what all that gobbledygook is. Those are hashes. What's with all the weird numbers and stuff? Whenever you do a commit, Git does a bunch of weird math and division and rounds things, and I don't know what it does, but it comes up with this unique identifier, and that's called a hash. And it's your identifier, it's your handle to that commit. If you need to address that commit, if you need to go back to it or see what it was, you just need a way to identify it. That's what that hash is. It's the identifier for that particular commit. Now they're unique enough that under most normal circumstances you can just use the first 7 characters as your identifier. So if you see here, the actual commit hash is that huge 7237883 blah 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 that ends in FF1. But when you do the one line, it just gives you the first 7, and that's something to make it easier for you to use the hash. So if I wanted to see that log, I'm just going to copy this because I'm not going to remember that. But I can type in git log and then pass it that, and it'll show me just that one. So you just need to know the 7, the first 7. Sometimes it's even less than that if it's very unique. So that's what that's for, and we'll use that a lot. The next command is git diff. It shows changes between commit and the working tree, etc. Basically, it shows you what has changed. So if I go back into that file and I add in another Avenger. What are the Avengers? Captain America. Did you say Iron Man? Captain America is an Avenger, right? So I'll close that, get out of dizzy mode. If I do a git status, you'll see, hey, Avengers has been modified, something's changed. If I want to know what, I do git diff, and it tells me this file changed. There's a difference, It says that Thor was removed, but it wasn't because it's re-added in the next line. But it does show that Captain America was added. So now I know I can commit this. I can say, oh yeah, git commit -m. Oh, I didn't add this. I'm going to do git add. So now it's ready to be added. Git commit -m add the cap. So now Captain America's in there, good to go. So now let's talk about branches, because sometimes you need to leave what you're working on. Sometimes you need to work on something else before you're done with something, or you might want to try a new feature or something that you're not sure you want to commit to your actual code base. Just need something to experiment with or whatever. So that's what branches are for. To see all your branches, you just type in Git branch shows you all your available branches. So I'll do that. Git branch. I'll clean this up quick. And the default branch that you're in always is master. That's what I like to call the root branch. The root trees. Yeah. All right. So that's the root branch. There you go. And if you want to add a branch, you type in git branch and then the name of the branch. That creates a new branch which mirrors the current working directory. So what that means is it's going to take the files that you have and it's going to copy them. It's going to make an exact replica of it. So I'm going to create a new branch, call it Spider-Man. So if I type git branch, you'll see there's a master and a Spider-Man. So I've created it, but that little asterisk tells me that I'm still in master. If I want to move into that branch, I use the checkout command. So git checkout and then the name of the branch. That will put me in it. So git checkout Spider-Man. And it tells me switch to branch Spider-Man. If I want to do git branch, take a look. You'll see the asterisk is now on Spider-Man. You can do all that with just one command. Git checkout -b and then the name of the branch will create the new branch and put you in it. So if I do git branch villains and I do a git, oops, that's not what I wanted. So let's move on to the next command. How to delete a branch. That would be git branch -d and the name of the branch. So since I created a branch called villains, which I didn't want to do yet, I can do git branch -d villains. And it says that branch is gone. So git branch shows me villains is deleted. So now what I wanted to do was create it using checkout command. So git checkout -b villains. So now it says I've switched into the branch. So you can see it didn't just create it, it also put me in it. So oops. Showed you how to delete a branch. So let's pretend that I made a change. I'm in the villains branch. So you can see all the files are still the same. It doesn't look any different than the last one. But if I go ahead and make a change to this Avengers file and put Spider-Man in there. You know, Spider-Man's not in the current Avengers, but you know what I mean. So if I do a git status, it shows that there's a change, so I'm going to go ahead and git commit that. Add Spidey. What did I forget to do? Forgot to add it. Now I can commit it. Spidey's been added. The file has Spider-Man in it. Right there. So now if I go into a different branch with the get checkout command, and go back to master, it says I'm back in master, and if I open that file again, nothing's changed. It doesn't look different, but you can see Spider-Man is gone. It's in that other branch. So it's a mirror of the branch, and it keeps the changes between them. If I want to delete a branch, I've showed you how to do that, but if there's something in it that hasn't been merged with the branch that I'm in, it's going to throw an error. So if I try to delete villains again, it should complain that the branch villain is not merged. There's something in there that doesn't match the branch that I'm currently in. If I wanted to force that, I just need to change this D to a capital D. And it says, fine, you know what you're doing. It's gone. So if I do git branch, you'll see it's just Master and Spider-Man. Now before I talk about merge, I want to show you something. I'm going to go into Spider-Man. Check out Spider-Man. Alright, so I'm in Spider-Man. I'm going to add a new file here. I'm going to call it villains. And I'm going to add, I don't know, Dr. Octopus. No, what's that new guy? What's the new in Avengers movie? Age of Ultron, is that what it is? Ultron. He's cooler. So we've got that in there. I'm going to go ahead and show you there's a change. I'm going to git add it. I'm going to make a commit. Add villains. Okay. Get back into my master branch. Then I'm going to make a change. You can see the villains file isn't here right now, but I'm going to go ahead and add another Avenger to this file. Iron Man. Yeah. So I've added Iron Man. I'm going to go ahead and git add. Don't forget git commit -m add Iron Man. All right. So if we look at our log, git log. See, I've added the Captain, I've added Spider-Man, or I've added the Iron Man, and added the initial Avengers file. Now, before I talk about merging, I'm going to talk about the exclusion to my only use the command line policy. There's this great program called SourceTree. It's free. It's from Atlassian, and it's a graphical user interface, and I use it a lot. But I only use it to look at my changes to see what's going on. It makes it a lot easier to visualize. So if I do this, it'll open it up. And now you can see the changes that were made. And this is where branching, you can see it, how it's branched, right? So you see that purple one, that's the Spider-Man branch, and it branched away when I added Captain. So, but I proceeded, I put something on top of that, and I added Iron Man. So you can visualize that a lot better with a tool like this, and you can easily click on it and see what all the changes were, and it's just a lifesaver, and it's free. So now let's talk about branching or merging. When you merge, you're basically taking the changes that are in a branch and pulling them into your working directory. So if I switch back to master and I merge Spider-Man, it'll take the changes in Spider-Man and put them into master. So that's what we'll do. Okay, so I am in master. So I'll go git merge Spider-Man. And then it asks me, it opens up Vim, and it wants me to specify a message explaining what this particular merge is about. If you don't know Vim, the way to get out of this, just :Q, or you can change the message if you want, but I'm just going to leave it merge branch. And that's it, we're done. It shows me that a merge was made. It shows me what has changed. And if we go back and look at this, you can see what it did. It took the changes in that branch and it pulled it right up there where we're supposed to be, where the changes were made. Alright. So yeah, SourceTree, it's a great app. Learn the command line. Don't use it for anything but viewing until you're really good at it. Bless you. And it feels GUI. It's nice. Windows or Mac, it's cool. Now, sometimes you screw up, right? We're not perfect. We're not machines. So sometimes we screw up, but we are perfect, right? It's actually the cat. Let's talk about the scenario. Sometimes cats get on our keyboards and screw things up, and we need to fix it. So let's pretend for a second that my pesky cat walked on my keyboard, typed a bunch of garbage, and somehow managed to save the file because he's a talented cat. If I do a git status, let's see a file's been changed. I don't want that change. I can go in there and edit that text file and, you know, delete all the stuff he entered, but there's a better way around it. There's this command here called git reset, and what that does, if you use the -- hard parameters, is it basically wipes away your changes. It goes with your last commit That's what head is. Head is the last thing that was committed. So it'll undo any changes since the last commit. So we'll go ahead and try that. Now the difference between hard, there's also soft. Soft will keep the changes that have happened. It won't overwrite them. But in this case, we'll use hard head. And it tells me that the check-in it's at now is when we merged Spider-Man. So if I go ahead and open up this villains file, you can see it's just Ultron again. All the changes are gone.
What's that head?
The head is basically where in the log of changes you're at.
So that's the point that you reset to?
Right. As far as commits, the last commit is head.
Oh, okay.
Going on that, there's a way to go back further, right? So this up arrow, it's a caret, I believe it's called. This will actually take you back one commit. So I'm currently at this commit where we merged Spider-Man. But what if that was accidental? What if, well, let's go back. Let's pretend that cat, messed up this file, saved it. And it was 5 o'clock in the morning. I wasn't paying attention. I'm like, git status. Yeah, there's a change. I don't know what it is, but screw it. I got to commit this because I'm going to bed. Git commit -m, too tired. Right, so we've committed that, and now that's our last commit. So, it's in here, too tired, and I wake up in the morning, I'm like, what the hell was that? What? This is garbage. I don't need this. How do I get back? If I do a git reset head, that's not going to do anything for me because I'm already at that point. But if I want to go back one to Spider-Man, I do that git reset head with an up arrow. And that will get rid of it. So you can see it's back now at the merged branch. So completely gone, never happened, you got no proof, right? So that's what, and you can keep doing that. You can keep adding carets. You want to go back 2 commits? Just add 2 carets. 3 commits? 3 carets. You can do this till the cows come home. But that's boring. This command here, the get ref log, is what saved my life. I had a gambling problem. I was an alcoholic. But then I found this, and life is wonderful. The ref log is a history of all the changes to head. So basically a history. The head isn't just a commit, but the head is where you've committed or where you've done another action like merging or a branch, something like that, where you've shifted what you're doing. That's what the head was. So there's a log of all the heads, and it's git ref log. So if I type that in, git ref log, you'll see everything. Starting from the bottom to the top, the very bottom one is the initial commit when I added that file. The second one, I added the captain. The third one, I moved into the Spider-Man branch. The fourth one, I went into the villains branch. The fifth one, I added Spider-Man. And you can see just the history of everything I've done. And this is what will get you fired. Because you can delete, you can go back, do that git reset head and get rid of everything that you think anyone can see. But this is still here, so you have a history of everything, permanently. But it's also a great tool. It's a valuable asset because it also means that you can't screw this up. You can't delete something and then never get it back. You can't completely ruin the project. As long as this is here, you can always go back to a different time. This is the time travel we're talking about. And it's a lifesaver. It's the best tool I have because when you're learning Git, you make a lot of mistakes and you type in the wrong commands and then you're just like, I'm screwed, I need some help. Well, no, you don't. You just go back to before you screwed up, and you're good. The beauty of it is you can go back based on the hash. You can go back anywhere. So remember I said you can do head. If you do head right now, if you do that get reset head, it'll take you to head 0. If you do 1 caret, it takes you to head 1. 2 carets, head 2. But what if you wanted to go to 12? That's a lot of carets, So you can instead use the 7 digits at the beginning there and go back to that particular commit. Undo all your work. I'm not going to do that. What you can also do is you can make a branch out of your previous work. And that's amazing, because if I want to go back to before something screwed up, but I don't want to undo everything I've done, I can just make a branch out of it. And the way you do that is just like you create any other branch. You do get checkout -b and then a branch name, but then you put those 7 digits afterwards. So let's say I want to go back to the beginning. So copy this, and then I do get checkout -b day 1, call that day 1, and then I pass it that hash, and it'll say I've been switched to a new branch called day 1. And if we go back and look at the files, the villains file is gone. The only thing in here is Thor. So I've gone back to day 1 in a new branch. So as you can see, there's Master, Spider-Man, and day 1. So if I go back to Master, everything's back. The villains file is back. My Avengers are all there. Well, 3 that I've added. So it's a good way to jump back and forth between your history. And it logs everything. So you can see I just moved into day 1. That's there too. So that's now where my head is. Not here. And that's it. That's pretty much all of it. Wow. Fast. Also I want to talk about the Midwest Dev Chat. There's this chat room. There's like 300 of us in it. It's a Slack room. Go to this website, Midwest Dev Chat. Request an invite. Somebody will send you an email letting you in. We're there all the time. There's a bunch of different rooms for different languages and different databases and whatever, music. A room for everyone. If there's not something you want in there, you create a new room. It's a great place to talk with people, and there's a bunch of us here today. There's Stewie right there.
Is that a wrapper for like MIRC or something?
No, it's Slack.
Oh, okay.
Yeah, Slack is, you know HipChat? No? Okay. So Slack is like HipChat, but better. And HipChat is like IRC, but better.
Gotcha.
So yeah, you can post GIFs. This is where I learned about all these GIFs and stuff, and we just bomb each other with stuff all day. It's great. It's a good resource. A lot of great, smart people that'll answer any questions that you have about whatever. It's awesome, and it's free. Just go to the website, punch in your email address, and get in. Join us. It makes meetups more fun too, because we're actually meeting here for the first time ever. And we've been talking for months on this thing. If you have any questions, I was going to say just send them to Nick Nisi, because he's really smart, and he's who I go to with questions. But if you actually have a question that he can answer, I'm sure he's more than happy to do it. As you can see, I like to delegate. So fire away. Go ahead. Anyone? You.
How is the, I see you have an Apple, whatever it is up there, but how does this integrate with Visual Studio? What's the integration like?
Git works on the file system level.
Right.
So I mean, so there are graphical interfaces for it. So like I use a tool called RubyMine for a lot of my development, and it does have a really nice graphical interface for using Git. However, I tend to agree with Viz. I'm not a huge fan of using the graphical interface. So I guess I'm not sure if Visual Studio has a graphical interface. But as long as your project is being stored as files, you can use it with Git. There's no.
Visual Studio does have an interface.
What's up?
Visual Studio does have an interface.
Okay, I would
It's not
imagine
the greatest.
so.
I've heard of people having a lot of problems with it. I use SourceTree, Tortoise, Git, GitHub's Windows, just with a combination of all of them.
Yeah, it might take some fine tuning, but you can get it to work if you're really persistent. But using the command line is probably the best thing.
Yeah.
It just seems like a lot of back and forth. I use HT, Mercurial HT is pretty much. Does that work similarly?
I haven't used that one.
Not Mercurial, Tortoise.
Oh, sure. Yeah, it's just like if you use like the TFS interface within Visual Studio, it's very similar. It's built in just like that, a little bit different.
All right.
Just like it was with tools. Okay.
But that's for the icons and stuff to show up. Yeah, okay. And we're using HG or think about moving to Git. I was kind of trying to compare how it works.
Anything else? No. If you loved all the GIFs, send this guy a tweet, because I'm doing this because of him. He gave a talk last year at bar camp about using GIFs in your talks, and it was the best thing ever. So.
Is that like webcam?
Yes, he's been sitting there all day, nodding yes, waiting for this moment. You can go now. If you still need to get a hold of me and you're not in Midwest Dev Chat, which I think you should be, I'm going to say that again because I think you should be in Midwest Dev Chat. It's the best place in the world. Lots of cool people, really easy to get into. MidwestDevChat.com. You should do it. If you still want to get a hold of me, this is how you do it. My email, skidvis@skidvis.com, Twitter @skidvis, website skidvis.com, whatever. And that's it. Thank you all so much.